Okay guys, we're gonna do a Unit 6 review. I'm gonna do the entire review, but since the test is tomorrow, I'm gonna make this really quick. Try and do my explanations and stuff, but yeah, so I'm gonna get straight into the video. Alright, so number one, graph to the right shows upper and lower sums for the function f of x equals square root x plus 1, and then using four subintervals. Which of the following correctly approximates the sum using the right hand endpoint, alright? So immediately, we're going to use right Riemann. So it does say that graphing calculator permitted. So I'm just going to get my calculator and do that. And if you don't know how to do that, you should have a program installed already for this. But if you don't, I don't know what to do for that. Alright, so in order to do this, you're going to have to go to y equals. And you're gonna have to set up your equation. So let me see if I can pull something up for that. Alright, never mind. I'm just gonna have to explain it. So you're gonna press y equals on your calculator, put in the function square root x plus 1, and then you're gonna go second mode, go back to the main workspace, and then when you have the program installed, you're gonna press program, press enter on TI basic, and then go to RAM, and then it'll say program RAM. You're gonna press enter. Alright, so your A is gonna be your first interval, or like your starting point. So we start at 0, we'll put 0, and then our B is gonna be our end point, so we start or end at 1, so we'll put 1, and then number of subintervals, we'll put 4. Press enter, it'll give us left, mid, right Riemann sum, and we're finding right. So it says 1.768 should be the answer, so that's number 1. Alright, which of the following definite integrals represents the area of the shaded region? Okay, so first it goes off by 1, 2, -1, -2, alright? So we know it's going to be from -2 to 2, and then we don't know the function. I'll just say f of x. Okay. So what I see is that if I do the integral from 0 to 2, so like all that, it's like some area. But then if I do from -2 to 2, it's that area times 2. So you got this. So it's really just multiplying this blue area times 2. So first, let's see, and we know that it's at 0, 0, so it can't be B. And then for this, it just doesn't seem right. And then I'm just gonna cancel that out. I don't really want to explain it. But so now we got C and D, alright? So we said how the red and blue, the blue is just 2 times the area. So like if you add these up together, it's just 2 times the area since they're the same, because it's a symmetrical function. So because of that, it should be D. Alright. Number 3, lower the sum of f of x equals square root x on the interval 0 to 1 with 4 equal subintervals is what? So first, it says lower sum. Alright, so in order to find out like what Riemann sum, we can just just imagine what the graph looks like. It probably looks something like that. And then I know it should be the left Riemann sum, because when it means lower sum, it just means like underestimate. So it probably looks something like this. Right Riemann is going to be overestimate. So we're going to do the same thing. We got to go into y equals and plug in square root x, back out, and we got to go to program, TI basic, RAM, program RAM, and then plug in your interval from 0 to 1 for A and B, and we got 4 subintervals. Alright, so you're going to get all your left, mid, right Riemann sums, and we're going to find our left, so that's 0.518, so the answer should be C. Alright, this one was a little bit weird, but we got the answer today, so I'm going to show you how to do it. So we have f of x being a continuous function. What is the value of the integral from 3 to 15 of f of x if it's known that 1 to 5 of f of 3x equals 7. Alright? So here's what we're going to do. We're going to do u sub. So I'm just going to focus on this integral. So I'm just going to write it out again. There's two methods, but I'm just going to do u sub. So first, I'm going to let u equal 3x. Alright? So u equals 3x, and then do the original method, you know, like du equals 3 dx, and then solve for dx. So du over 3 equals dx. And remember, when you put it in terms of u, usually you can change the bounds. So I'll do that right over to the left hand side. Alright, so u of, let's see, u of 1 equals 3, because we're just doing 3 times 1. And then u of 5 equals 15. So our lower bound is 3, upper bound is 15, so now we can change it. So I'll put it right here. So from 3 to 15, we have f of u over 3 du, which equals 7. This is also the same thing as just doing, let me see, f of, or just 1/3 times the integral of that. And then you can multiply both sides by 3. So you get this f of u du equals 21. So that's it. So we shouldn't change the u back into terms of x because we changed the bounds. So we got our answer is 21. So therefore the answer is 21. So another way to try this out is by like doing an example function. So if you want to try it out on your own, you could do like f of x equals x squared, and then f of 3x equals 9x squared. And then you could plug that into the integrals, and then you're gonna get a scalar, or like a scale factor of 3 no matter what. So therefore number 4C. Okay, so we got number 5, which says which of the following integrals can't be found using any of the basic integration formulas or techniques from unit 6. Okay, so we're just gonna solve each one, see if we can actually like try and figure it out. So for A, I'll just write it right here. So we got u equals, we can say x squared, and then we have du equals 2x dx, and then you get du over 2x equals dx, and then now you gotta plug that back in. So I'm just gonna write it to the side over here. So we have x cubed over 1 plus u squared, and I'm gonna quickly just erase that. So I'll just say, no, I'll just write it right here. And then that's times du over 2x, and then let's see. Oh, never mind. Should be x to the 4th. Let me see. So let's see if you do x to the 4th. So then du over 4x cubed equals dx. Let's see. Does this work? Yeah. So now the x cubes cancel out. And then you'll get 1/4, because I'm bringing out this 4 right here, of the integral of 1 over 1 plus u squared du. And then you can try and solve from there, but that should be able to work. I think I did the method wrong, but yeah. Alright, so we're going to B, so therefore it can't be A. So now we're going to B. We do the same thing. So this time I'll set u equal to x squared, and then du over 2x equals dx. And I'll just write it to the side again. So you got x over 1 plus x to the 4th times du over 2x, and then rewrite that. So the x's cancel out, and then this x to the 4th is just going to be u squared. And then for this one, this should just be 1 plus u. Yeah, alright. Anyways, so you get 1 over 1 plus u squared du, and then yeah, I think you also should be able to solve it from there. If not, then I'm just doing it wrong. But yeah, this is like pretty late. All right. So because it can't be A or B, because you're able to like use like u sub to try and like find the integral, that means the answer should be C. And if you try to do u sub with this, it's not going to work out. So yeah. All right. So now we're going to go into FRQ for calculator. So let's see. So fish enter a lake at a rate modeled by the function e. So we got fish entering a lake at a rate. That's pretty important. So it's a rate. So you got e of t equals 20 plus 15 times sine pi t over 6. And then fish leave the lake at a rate as well, modeled by the function L, so which is just 4 plus 2 to the 0.1 t squared. So this means how many fish are entering and leaving per hour since midnight. Alright. So for part A, it says how many fish enter the lake over a 5-hour period from midnight to 5 a.m. So in order to do this, all we're going to do is go to e of t because we want to find how many fish enter. That's it. So we're going to take the integral of e of t, and it says from t equals 0 to t equals 5. So therefore, your lower bound is going to be 0, upper bound would be 5. And then I'm just going to write e of t, in this case, dt. And then because this is a graphing calculator, it's allowed, you're just going to put that into your graphing calculator. So you're just going to go math 9, lower bound 0, upper bound 5. And then e of t, make sure you're in radians, it's just 20 plus 15 sine pi x in this case over 6 dx. And then it does say give your answer to the nearest whole number. So you should get 153.457. So let's see, equals 153. Oops, let me redo that. 153.457. Alright, and then we gotta round that, so that's just 154 fish, or no, 153. And then like a full sentence would be like 153, or let me type this out actually. I guess like 153 fish entered the lake between midnight to 5 a.m. something like that. Alright, so now go part B. Alright, so what is the total number of fish? So we got total number, so this is different. So in order to do this, and it's the same time at 5 a.m. So we're going to take the integral again, because when we integrate these functions, it's just going to give us like total amount of fish that have left or like entered. So the total number from 0 to 5, this time it's going to be e of t minus L of t. So you can do the same thing, alright? Plug that in. This time you're just going to do e of t minus L of t. So let's see what happens when I do that. So I'm going to do 0 to 5. 20 plus 15 sine pi x over 6. And then I'll do minus, what is it? Let's see. 4 plus 2 to the 0.1 x squared, and then dx, and then you should get 123.163. I think that's it. And then just round that to the whole number, nearest whole number, and then you get like 123 fish. And then you can just say like 123 fish. Oh wait, like the total number of fish in the lake was 123 fish at 5 a.m. Something like that. Okay. So now we're going to go into part C. This time, it's asking, is the rate of change in the number of fish, so this is really important, alright? You'll see later. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. Okay, so when you're trying to do this, you might think it's just E of t and then like L of t and then checking which one is bigger. I made that mistake today, but then I checked and I realized like, well, I did it wrong. Because it says the rate of change in the number of fish. So this is just how much fish are coming in and out per hour. But it says the rate of change in the number of fish. So like it's kind of weird how it's said, but essentially you just take the derivative of those two functions. So e prime of t, and then you're going to subtract it. So you're going to, because you want to see like if the total amount of fish per hour squared, I'm pretty sure, is like increasing or decreasing. So if you want, you can plug that in, and I'm going to see. Because to be honest, I have no idea how to do this one. I had to check. So yeah. Let me see. Okay. So yeah. All you're just gonna do is go to math, and then you're gonna do derivative, if it's even a thing. Yep. So d over dx. And then just in case, I'm just gonna write out the answer right here. It's like negative 10.722, I think. Alright guys, this time I'm going to do 6D, but on a new program just because it's easier. Alright, now it says at what time t for 0 less than or equal to t less than or equal to 8, so just from 0 to 8, is the greatest number of fish in the lake. Alright, so basically that means like at what time do we have the highest amount of fish. So because of that, I immediately think of max. Alright, because of that, I know we're going to use like a derivative test or whatever. Or like if we're to do critical point. Oh shoot. Alright, there. Crit. Let me just change this to like blue. Alright. So now we know that from the integral from 0 to x, this means like any time, like however many hours for after midnight, of e of t minus L of t is dt. Alright, we know that, like, that's how many, like, total fish are in the lake after how many hours of midnight. So what I'm going to do is I'm going to set this to equal to capital F of x. Alright? And we know from the theorems of calculus that this is also the same thing as, and we know that, actually, yeah, when we take the derivative of this, you know, apply the derivative of both sides, right? You get capital F prime of x just equals e of x minus L of x. Alright, we should know that because we did it. If you don't, now you know. Alright, so back to this with the max and the critical point. I know I'm going to have to set this equal to 0. Alright, so capital F prime of x just equals 0. That's the same thing as setting this equal to 0. Alright, so this question is also calculator. So basically, what I'm going to do is I'm just going to graph e to the x minus L of x on the graph, right? So you got to go to y equals, plug that in. And when you do that, you should get like x, or in this case t, equals 6.0 235. Alright. Let me just delete this because Arvin wants to troll around. Alright. So when you do that, you'll get t equals 6.0235. Or just 6.024. So that's the time that it's going to have the greatest number of fish. I know that because on the graph, so just like draw something like this, you know, the line, it goes from positive to negative. Alright? Everyone ignore this. He's trolling.
Can we get a van?
Yeah. Alright. But yeah. So like it's crossing the line, this thing, because it's positive. And remember, it's the derivative. This line is the derivative, f prime x. So this thing goes from positive, so plus, and then to negative. Oops. So it's going to look something like this, like a max right there on the original function. Alright, so in order to find how many fish are occurring at that time, all you got to do is plug in 6.024 back into the integral of x. Alright, so just like this. So from 0 to 6.024 of e of t minus L of t dt, you will get, let me see. Let me do the math. Or actually, let's check the answer, because I have it. So when you plug it in, let's see. Oh, never mind. I'll actually do it myself. Alright. So you get, I'm going to write it out. So 6.024. This is what? 20 plus 15 sine pi t over 6, and then minus 4 plus 2 to the 0.1 x, or t squared. And then dt. Alright, so now you can plug that into the calculator. So I'm going to do that. Alright, so from 0 to 6.024. Ignore that. So yeah, so plug this into the calculator, put your bounds in, and then I'm just gonna put all of this into the calculator, and then just put it in terms of x instead of t. You know, so we got pi x over 6, and then minus, let's see, 4 plus 2 to the 0.1 x squared dx. Alright, let's see. So it says that the answer is 134.7, and I'm just gonna round that to the nearest whole number. So 135 fish. Alright, and then when you wanna write that out, since it's a FRQ, all you just wanna do is say like time t equals 6.024 or 35 has the greatest number of fish, which is 135 fish, something like that. I don't know, but that should work out. Alright, so yeah, that's really it. So tomorrow's calculator, I'll post non-calc tomorrow, maybe with Eric, and then yeah, and then Arvin wants to show a little gift, so yeah, this is his little gift. Alright, see you guys tomorrow.